Today we're going to look at numerical integration, and particularly we're going to be looking at the trapezoidal rule. So first off, we're going to sort of build up and explain the concept that's going on here. So our first problem, our problem here is that we need to estimate the area under a curve over an interval from 4 to 12. And we are given this table of values, so we're not really given too much. What we'll do to start off with is we can make a bit of a sketch of the information that's provided here. So there's my y-axis, there's my x-axis, when x equals 4, y is going to be 5, so we're here. When x equals 6, it's 13, so we're here. When x equals 8, it's 10. When x equals 10, it's 3. And when it's 12, it's 4. So the information that we've got looks like this. The information that we've got looks like this. We have no idea what the function is. It could be a variety of different possibilities, but as long as it's a continuous function, we can find the area. Let's say the function looks maybe something like this. Could look like that, couldn't it? There could be different alternatives though, couldn't there? So we are going to find the area under this curve using trapeziums. So our first step is we are going to look at this first trapezoid. So here's our trapezium number 1. Here's trapezium number 1. Number 1 is going to have what area? How would we calculate the area?
4 times 4.
Sorry, let me go back a little bit. Let's get the heights. What is the height of the line here?
5.
5. What is the height of the line here?
13.
13. What is the perpendicular distance between these two parallel lines? 2. This is the information that we need. So the area of this is going to be what? 5 plus 13 divided by 2 times by 2. So it's this distance here, 2 times 5 plus 13 divided by 2. What will that give us? 18. 5 plus 13 divided by 2 is 9, times 2 is 18. So that one's 18. So we need a second trapezium. That one would be here. What would this height be? 10. Distance is still going to be 2 between them. So the area of this one is going to be 2 times
13 plus 10 over 2.
13 plus 10 over 2. And that will give us 23. How many trapeziums will we have to find the whole area? 4. So we need this trapezium now. What's this last height over here?
3.
3. Thank you, Austin. So trapezium number 3 is going to be 2. That's the horizontal distance times
10 plus 13
10 plus 3 over 2. That's 13. trapezium number 4, our last one. This one here, going a bit wider, still only 2. The area here, 2, sorry,
You know, 2,
2 times
3 plus 4
4,
over 2.
3 plus 4 over 2, that's 7. What's the total area under the curve in this interval, or at least an estimate of it? The area we're after is going to be the sum of all of these. So it's 18 plus 23 plus 13 plus 7. So that's 20, 43, 53, 60,
61.
61. So we calculated each area. I'm going to show you what I'm doing here is this is how we would do it with trapeziums. We have a formula for it. The formula is difficult to read and understand. So if I go this way, you'll get an idea, okay, this is where everything's coming from and it will make sense. So this is the big picture concept. So what we're going to do now is I'm going to build towards the formula by looking at the calculation we just did. Looking at the calculation we just did. This calculation for the area was the sum of all of these. So the area was made by, where did the 18 come from? Well, it comes from this, doesn't it? It comes from that area, that first trapezium, 5 plus 13 over 2. And then this 23, where did that come from? Second trapezium. So 2 bracket 13 plus 10 over 2. And the 13, where does that come from? The third trapezium, 2 times 10 plus 3 over 2. And this 7, where does the 7 come from? 4. 2 times 3 plus 4 over 2. Now, there's some repetition in this formula. They're all multiplied by this 2. What is this 2 that appears in front of the bracket? Where does that come from? No.
It's the difference between the first x and the second. It's the difference between each x.
Yeah, it's these distances here. It's these distances here. So because that 2 appears in front of all of them, it's that distance, and let's call that h. So it's the difference between these two, between this minus this, 6 minus 4. We'll call that one h. So that 2 we can pull out, we'll factor it out. But notice how every single one of these is divided by 2. Where does that 2 come from?
The trapezium formula.
It comes from the trapezium formula, and it's basically finding the average of the 2 heights, the two long sides. We find the average length of the 2 sides. That's what that is. You add them together, divide by 2. It's average, mean. Anyway, that half is there all the way through. Let me factor that out. I'm going to factor it out to here. I'm not going to cancel these 2 because that half is always going to be a half, but that 2 is not always going to be a 2. That's the difference between the 2 x values, and that could be a 1 or a 5, and then it wouldn't cancel. That's why I'm leaving it in here. So what's left inside the bracket when I factor all of this out from everyone? It's going to be 5 plus 13 plus 13. So let me just write it all out. Give me a second, Mark. 5 plus 13 plus 13 plus 10
Plus 10.
plus 10
Plus 3 plus 3.
plus 3 plus 3 plus 4. Is there any repetition in that?
The 10.
The 10, the 3, and the 13.
So I'm going to take this last number and this first number. I'm going to take this last number here from this first number, move them to the front. then there are two lots of all the other numbers. There are two lots of all the other numbers. 13, 10, and 3. Why are there two lots of all of these, but only one of these two?
That's the beginning.
This is important that everybody gets this bit. This is the crucial part. And it comes from, if you followed how we went through all of this when we're doing these trapezoids. Let me get my highlighter pen. This 13, that length there belongs to two trapeziums. There are two trapeziums that have a side of 13. All of the middle ones are on two trapeziums, but the end one and the first one is only on one trapezium. So the first number is only used once, the last number is used once, but all of the other vertical lines are used twice. So this gives us, this is where we get our formula from. So we are going to have a half times the distance between the two plus, I think this is a y, wasn't it? We want the first y value, y0. We want the last y value, yn. And then we want two lots of everything in between. That's y1 plus up to yn minus 1. So half is because we find, comes from the trapezium formula, we find the average of the two lengths. The h, that's your step size, that's the difference between each interval. We were going up in steps of 2 on this question. That's this number here, that's h, that distance there. y0, that's your first one. yn, that's your last one. And then two lots of all the middle ones, y1 to the penultimate one.
Will the distance always be the same? Or
Yeah.
Yeah.
The h will have different numbers, but the distance between the different steps will always be the same step size. Will always be the same size. Let's go look at this on the formula sheet now. Let's go look at this on the formula sheet. I think it is a tricky formula you have to get the big picture concept of how I did that manual version to see the formula and understand how it works. Once you get that, it becomes a lot easier to use. This one will take some practice using. So which section is it going to be in?
Calculus.
Calculus. This is calculus. Obviously it's going to be at the end, towards the end. So we down to the end. And it's the last formula, here it is. Here it is. So we've got a half times h, that's the difference between them. y0 plus yn, first and last. And then two lots of everything in between. Two lots of everything in between. The tricky one is how to calculate h. How to calculate h, the step size. Now in a lot of questions it's easy to calculate h because you can just see it there in the table. So for instance in this question here, it's quite easy to see h is going to be equal to 2. But if we're given a function and we're given an interval, and then we're told how many steps to make, we have to calculate h ourselves. And those are the hardest questions. Those are the hardest questions. We have to use this formula here. We have to use this formula here. It says b minus a over n. Now, what is b? What is b?
No, y note. Y note, like the last y.
No.
No, the last x.
It tells us here in the formula. It tells us here in the formula. So this b and this a, it tells us here that it's these. It's your lower limit of integration and your upper limit of integration. So a and b are your limits of integration. So b is your upper limit, a is your lower limit. So on the question that we've got, Our upper limit of integration is here. Our lower limit of integration is there. Our upper limit of integration and lower limit of integration. It tells us there in the formula, when we're doing the numerical integral, b and a. So we want b minus a, okay? What about n? What is n?
The intervals, like the trapezoid.
Nope.
It's how much you set to.
We've got n here in the formula.
Is that the one at the end that's by?
Huh?
It's like how much you.
In our question, n was 4. In our question, n was 4.
Yeah, it's the one that's the number of trapezoids.
In our question, n was 4. Sorry, Simon?
The number of
N is the number of trapezoids. How many trapezoids are we going to use? We're going to use 4 trapezoids. So n is 4. Let's see that that works. It says h should be 12 minus 4, b minus a over 4. That's going to give us 8 divided by 4. 8 divided by 4. 8 over 4. It's going to give us 2. We can see that in the table. It's a lot quicker and easier to do that.
So h is the step size and this
H
is
is the step size. And this is the formula for how to calculate the step size. Let's have a go at this one. So we don't have the table this time. This one gets a little bit trickier to do. We need to estimate the area under the graph, e to the x, over the interval 0 to 1, using 5 trapezoids. So first we shall calculate the value of h. First we shall calculate the value of the step size. How do we do that? Use the formula.
n is 5.
N is 5.
And then a minus b.
A minus b over 5.
Even.
So our step size b minus a over n. And then here in the question, what is the value of b?
1.
Where do you see that?
The upper interval.
It's the upper limit of the integral, upper limit of the interval, both. Upper limit of integration and the upper limit of the interval, same thing. So it's 1. What is the value of a?
0.
0. What is the value of n? 5. Why is n 5?
Because it's the amount of trapezoids.
It's the amount of trapezoids. As a decimal, this will give us 0.2. This will give us 0.2. So we are making a table. You don't have to put the table up. But if we were putting the table up, it's going to look like this. What would be the first x value in our table? 0. What would be the second x value?
0.
What would be the third?
0.4.
Good. The next one?
0.6.
The next one? The next one?
1.
Oh, 1.
0.10. 1.0. So these are, how many x values do we have here? How many x values do we have?
6.
6. How many trapezoids do we have? Why is there always one more than the number of trapezoids?
It's n max minus 1.
0.
Well, if we look at the formula, let me look at the formula here. If we look at the formula, here in this part of the formula, we are going, we have all the y values. It goes from y0 to n. So if n is 5, I'm accounting from 0, 0, 1, 2, 3, 4, 5. From 0 to 5, there are 6 numbers. From 0 to n, there are n plus 1 numbers. So we have n plus 1 columns to our column. What are our y values?
The first one is
The first one is 1. Third, I'm going to be lazy. The first number would be f of 0. What would the second number? F of 0.2. What would the next number be? F of 0.4. The next one?
F of 0.6.
F of 0.6. The next one? The last one?
F of 1.
F of 1. So this is we've made our table of data now, from like we had in the previous question, and added them all up. So let's go to our formula booklet. Let me hand the formula booklets out. Find the formula booklet. I'm going to hand one out on each table. Find the formula in the formula booklet. Bring up a notebook. Find the formula. At the end of class, make sure you return the formula booklets over here, please. One for me. Okay. So, our formula says the integral from 0 to 1 of e to the x with respect to x is approximately equal to
1.72.
a half times, what's our value of h?
0.2.
What is h?
The distance.
The step sign.
The step size, the distance between the x values. So 0.2. Then we need our first y value. What's our first y value? F of 0. Then we need our last y value. F of 1. And then we need 2 lots of every y value in between. 2 lots of every y value in between. So that is f of 0.2 plus f of 0.4. Can't quite fit it in. Plus f of 0.6 plus f of 0.8. We have to type this into the calculator. Now this is the hardest part. Everybody who doesn't have a calculator, raise your hand. So anyone in the room, I need to see hands. I don't see any hands in the air. 1. Are you indicating you don't have your calculator? Everybody else, get your calculator out, warm them up. Alright, this formula is very tricky to enter into the calculator. Students make a lot of mistakes typing this in. About half of you get this wrong because you just simply can't type it into the calculator. Be careful with your brackets. Let's do this one together. So we'll do this one together. Let's start off with a nice new fresh calculator. So let's press on, press 1, and say no, don't save. And then we'll add a calculator page.
I think it's better if you plug in the x values to the function. So, yeah.
So We are going to add a page. We're going to add a graph page. Come on, follow me along. We're going to add a graph page. And here we're going to put the function in. So we have the function e to the x. This is our function, e to the x. Press enter, go back to the calculator page. We're going to type in the full thing, so we have a half, put in a half, times the step size. What was the step size? 0.2 times bracket. Now be careful, it's all about your brackets. That's where your error is going to be. It's all about your brackets. Particularly this one in front of the 2 and this one here. So these brackets. So the first one we want, we're going to use the function here. So press function. We want f of 0, close bracket, plus. And then we want f of, what was it? 1? F of 1, close bracket, plus. And it's this 2. 2 lots of times. And we open up another bracket. Notice we should have 2 sort of brackets here at the end. And in here, we want to put all of the ones in between, from 0.2 to 0.8. So in here, for each of your functions, f of 0.2 plus, and then put them all in, f of 0.4, close bracket, plus f of 0.6, close bracket, plus f of 0.8. Once you've got it all in, we should get this value, 1.72.
Sir, I got 2.5.
Yeah. Put your hands up, I'll come around and spot the mistakes that you've made. Yeah. If you don't know how to pull up the function on the calculator page from the graph, I'm not sure how to do it on that one, I can't remember at the moment. Just type e to the 0.2, e to the 0.3, and so on. So if you don't get one, I need to see 1.72 on your calculator before you're allowed to progress.
So do you know how to put it up on the calculator?
Yeah. Alpha F4. So we'll press the alpha button, F4, and then we'll open up a bracket, 0, close alpha, F4, enter, 1, close the bracket, plus 2 times bracket, enter, 0.2, once you get 1.72, let me see it.
What did I do wrong?
Sorry, let me pause the video a few minutes while people type this one in. It'll take us a while.